Yeah, I know.
I'm glad you guys
Not even insurance.
Does anybody have another name of another category they might use to substitute? Are you thinking Pythagorean or quotient?
I thought Pythagorean quotient.
I think I would think quotient too. Pythagorean wouldn't be ridiculous, but it wouldn't be easy either. Pythagorean wouldn't be impossible, but it wouldn't be easy either. I think I like quotient and reciprocal.
Fine, I'll stay on. Okay, I'm just gonna split it, I don't know. Or, because you turn into 1 over sine x. So, if I do that, then you put on the 2 yeah. Dang it.
Why don't you guys take a peek at how I use the quotient and the reciprocal property?
Right! No, I don't know what I'm doing.
Pause. Quotient and reciprocal, what do you think? Does it make sense? It's not the only way. Pythagorean people, you should have been able to get there also. Might just be a little longer.
Why did you say it? Yeah, because this technically means
So tangent is square. Notation for that. So I did the quotient property, cosine over sine, and I brought the square back in for the Does that make sense? Do you guys need to see how I got this one? I knew what the notation was for the squared, and so I took my cotangent, the quotient property, and then I brought the squared back in for the notation. Now I did that quickly. We've done a little bit of practice, but that's technically what I did, just for the cotangent squared. I saw the notation really meant that I brought the quotient property in, and then I squared both sides. That's how I got from the top to the top, quotient property. And hopefully you guys see the reciprocal property. Now, why don't we like the form, well, pause, sorry. Any other questions about how I use the quotient and the reciprocal? No.
I'm confused on how it goes from cotangent to cosine. Or is it supposed to be?
Oh, the cotangent, pause. I did this jump quick. Cotangent itself became all of cosine over sine. So that wasn't using the bottom at all, just looking at the cotangent squared. So look at your quotient property, favorite table.
Yeah.
And cotangent of u or of x or of theta or of t can become cosine over sine. Does that make sense? There you go. So cotangent became cosine over sine. I squared both of them because of the square. And then this guy brought in the 1 over sine. Does that kind of make sense? And so cotangent flips it. Good explanation. We don't like this very much.
no.
Because it's a, what's that name for a fraction that has like a messy like fraction in a fraction?
Complex?
Complex is the technical term, but yeah, you can think of it as a double fraction, a really involved fraction, complicated because it's not imaginary, maybe complex isn't another way of saying it. A complicated fraction. But when you divide by a fraction, when you divide, big old division, when you divide by a fraction, what do you do? Multiply by a
reciprocal.
So couldn't I rewrite this to be the cotangent squared, which I have rewritten a different way, but this is all still cotangent squared, divided by, aka multiplied by the reciprocal of 1 over sine. Isn't that legal? When you divide by a fraction, you multiply by the reciprocal. How is that helpful? You see a sign on top and sign squared on bottom. So what can that become? Yeah. The sign is going to reduce with one of the signs down below. Like if you had an x over x squared, the x squared would just turn into an x. Let me show you that real quick. You can think exponent properties, it'd be 1 minus 2, negative 1. You can think this is x times x, 1 cancels, 1 remains. That's what's going on here. When you reduce, 1 goes away. So that's how I get cosine squared of t, all over sine of t. And some of you are like, oh, we're still not compared. We're still not there. But just a few of you are like, wait, there's something to do with cosine squareds and sine squareds in one. Which identity? Pythagorean identity. If you need to, go look at your table. Actually, underneath our table is where we wrote the rearrangements of the properties. Cosine squared
1 minus sine.
is 1 minus sine squared. It's a rearrangement of the Pythagorean property. Look right underneath the table that you wrote in your notes. Cosine squared equal, you put I think a u or an x, but it does equal 1 minus sine squared. Whew! Did we make it? So to show that, to document it, we go ahead and rewrite the 1 minus sine squared. That's what we wanted it to match. This is our rewriting of the problem. We rewrote the left side, that was the beginning, and now we're rewriting the right side to say, hey, rewrite it. We can use the QED if we want to look really snazzy. Like you know Latin, quote error to much, but thus has been proven. We could put a check mark. We could put a box with a little bit of shading in it. George Corey a few years ago, I think he wrote rubber duckies on all of his. One of the honors kids tried to show the Trump hair for all of theirs. I don't know, it's weird. Just show me something to be like, hey, thus it has been proven. Okay, what made this messy? Help me out. What made it messy? Fraction. I think fraction mathematically was probably the hardest part. But did you have to choose some properties to use from the very beginning? Yeah. But the fraction made it even worse. So here's what we're going to do. Let's get into our notes. Since I know fractions are hard, let me try to show you a shortcut. Did anybody try to go from the right side? Okay. If you did try to go from the right side, which I'm not going to show right here because that would be an improper proof if you go from both sides. Do you guys see how you could have made a few of you that are like, I think I can be creative. Let's see if we can do it mathematically. 1 minus sine squared could become what? Cosine squared. That would have been the second step after rewriting it. Cosine squared over sine. Well, sine could become 1 over cosecant. So maybe that would have been something that you plugged in. Cosine squared, here's where you would have had to get creative. How do I get cotangent squared from cosine squared? We've had to bring in something that wasn't there. We've had to multiply top and bottom. By something that wasn't there. Because to get cotangent squared, you needed an over sine squared. Then you could have gotten cotangent squared, and then that would have become cosecant. But you would have had to put in something that wasn't there, which is a little rough for a lot of you. But anyway, that's how you could have been creative, going on the other side. Okay. In your notes. We're not going to make these bell work just because we did an example instead to introduce this idea. That was what I called it a few years ago. Let me get rid of the timer because we don't need that either. There we go. However, I do want you to do really quickly in your notes. You don't even have to like put a heading on the left-hand side. We're going to call this a fraction aside. Let's do a complex fraction aside. Please remember, you learned the word complex way before, it would have been probably in elementary school, way before you learned about imaginary numbers. So, sadly, it doesn't mean complex as in imaginary, although you wish these were imaginary, but complex as in complicated. This is going to be a quick aside. Still put it in your section 5-2 notes. Because these fraction skills will be helpful. These fraction skills will be helpful. Let's work through together as a class. You guys have given me some input. How could you rewrite number 1? The way that you could solve it with the multiplying by a reciprocal idea. How could you rewrite it? Where would you put the division sign? Is it 2/3 divided by 5? Or is it 2 divided by 3/5? 2 divided by 3/5. Sometimes it's hard to see. I try to write the big old division that you would have seen in the problem as longer. That's my way of writing it. But this would be 2 divided by, I'm going to write it over here and you'll see why in a second. 2 divided by 3/5. How would you write number 2?
1/3 divided by 5.
Well, we're going to use this rewritten form to solve in just a second. But what would we do with number 3?
2 minus
Yeah, parentheses grouping this numerator, so that entire numerator divided by 4. Okay. How would we keep going on number 1?
2 times 5/3.
Good. Multiply by the reciprocal, so 2 times 5/3, yeah? Fraction work, let's go. 2 times 5/3. Which, some of you would need to think about, hey, the 2 is over 1, right? So then we end up with, what is our final answer? Sure. Number 2, what would you do? Yeah, good. 1/3 times, flip it. That one's even easier, right? That's just going to be 2 15ths. How about number 3? There are 2 ways to go about it. What do you guys think of dividing first, dealing with this, making it multiplying by the reciprocal? So deal with the division first, or deal with the parentheses first? Parentheses. Okay. So how would you do that? Do you have an idea, Joel? Yeah.
When the overall answer becomes over 8 times 4, and then use a section multiplier. But once you do the parentheses, it's 8 tenths.
Oh, got it. You're simplifying.
Yeah.
Okay, yeah. I don't know if I would have gone to tenths, but you could have gone to tenths. I probably would have just gone to fifths. That's why it took me a second to catch up.
Okay.
But what Joel did is he multiplied top and bottom by 2 over here and multiplied top and bottom by, I think, 10 over there. I would probably just say, hey, I have a denominator. So I would just multiply by 5 over 5, which would have gotten me 10 fifths minus 2 fifths. Oh, you're close. And 10 fifths minus 2 fifths would be 8 fifths. But yeah, you could have done parentheses, common denominators. Now you have 8 fifths divided by, oh wait, hold on. Wouldn't most of you need to think about that's over 1?
1/4.
Okay, good. So then times 1/4. You could have gotten 8 20ths, or hopefully you saw you could reduce, right? Final answer, 2 fifths. Did these require any algebra? No. Okay. So that means that it would have been something you learned how to do in 6th grade math, 7th grade math, pre-algebra, something like that, right? But how many of you coming in today, if I had just given that as a quiz, would have gotten 100%? Maybe, like, okay, less than a third of the class is like, I think. How do you guys think you could have passed it? Still not the whole class. And that's normal. So don't feel like it's abnormal. That's normal. Complex fractions, a lot of kids hate. Can I show you a shortcut?
Yeah.
This is possible. Did it work? Yeah, I've got 3 answers. Was it crazy hard? No, I could have probably explained it to a 5th grader. Would have been hard, they would have hated you for it, but you could have explained it to them what to do. Teach them multiplying by reciprocal if they haven't learned it yet. Teach them about PEMDAS, parentheses, before multiplication division. Common denominators. Okay. What's a shortcut? Looking at this fraction, and then these different colors. Looking at this fraction. Do you see the big old division?
Yes.
So who is really messing us up?
3/5.
And more specifically, the,
Fifth.
yeah. So I'm going to circle him. What's messing us up in this one? I don't like the third part. I wish it was just the one. And I also don't like the half. I don't like the half part either. What's messing us up here? Just the fifth part. Now look and see what I did, or what I'm about to do. I actually learned this when I was sitting in a Uganda secondary school classroom. I was like, oh, that's a cool trick. I'm going to take it back. You ready? Ask Mr. Park. He was there too. It was the same classroom. I'm going to take top and bottom, which I'm allowed to do. Didn't we multiply top and bottom by something right here?
Yes.
And that was legal because what does 5 over 5 actually equal?
1.
So I'm not changing the quantity. Anything times 1 is itself. I'm mathematically being legal. Ready? What if I was to multiply top and bottom by 5?
Whoa.
What's 2 times 5?
10 over 3.
This would be 5 over 1, because I'm thinking about a baby fraction. What happens to that guy? Dun, 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 dun.
Oh, what?
Sorry, I'm having a panic attack.
Oh my gosh.
Now wait. This has a 3 and a 2, so I multiply by 3 and 2? Yeah, what's 3 times 2? What's 3 times 2? No, it's a good idea. It's a good idea. Because multiply by 3 and multiply by 2, which would be multiply by
6.
So then I multiply the top by 6 and the bottom by 6. Okay? Now pause. Here's where it gets a little tricky. Let me move this down just a little bit. I need you to realize this 6 is not a fraction. The whole thing is, but the 6 up here, the 6 belongs kind of like a top. Okay? What happens to the 3 and the 6? 1 and a 2, right? Isn't that just 2? What happens to the 2 and the 6?
That equals 3.
What's 5 times 3?
15.
Oh, darn it.
What about this?
Makes it so you don't have to rewrite the problem. You get to do one step. And what am I doing? I'm getting rid of him. But what I do in one place, I have to do, if I do the denominator, I have to do it in the numerator. I'm getting rid of them and saying, ew, I don't like you where you are. Now here's a trick, number 3. What am I going to multiply top and bottom by? Just the 5. He's my only problem. The bottom's easy. 4 times 5 is 20. The top is where it gets a little tricky, but didn't we have to remember parentheses anyway? Even if we do it the old elementary way. Now what do I do with this 5? What's 5 times 2? 10. Minus, what happens when I bring the 5 in here? Don't think cancel.
Yeah.
What's left?
2.
What's 10 minus 2?
8 over 20.
And what does 8 over 20 reduce to be?
2 over 5.
2 over 5. Take it or leave it.
Take it.
I like it. Take it or leave it. I like it. Figure out who don't you like. Who are the little hidden denominators messing the whole thing up? Multiply top and bottom by the 1 or by both. And then it naturally simplifies away the complex fraction. Okay. Kind of spiffy. Not required, but I will be using it from time to time. Let me get rid of this whole page since we didn't end up using it. Why did I show you that? Well, we saw a complex fraction in the back of our spirals, and guess what we're about to see? Alright, write it down. Write it down, pick a side. Oh, hard. Which side is harder on this one?
The left.
Please go left.
Yes, okay.
If you try to go creative on the right, it's possible. It's just such a mess. Well, you have to create the math legally on the right-hand side. Some of you might like that challenge.
No.
You have to somehow get subtraction in. be rough. But number 24, if we start on the left, it's definitely complicated. The nice thing is, if you guys at least draw the T and start with the side, you get 1 point out of a multi-point long answer type of problem. Quick heads up, chapter 5 takes a good amount of time to get through. I'm not splitting it up into 2 tests, because if I was to split it up, I'd split it up after this section, and it's a little too soon to have a test. And it's on some kind of tricky sections. I don't want to have a test on this. And I told you guys I'm splitting it up into formulas on one day and problems on the next, so you can use like a formula sheet on the problems and not have to recall and do problems. So I'm already kind of splitting up the test. But we are going to have a quiz on 5.1, 5.2, not a long one. Won't take all the class. But we will have a quiz. I think it's going to be on Thursday. Look at your calendar. Wednesday, homework is due, but I'm giving you an extra day. We might do some going over homework questions. Maybe I'll do it in an extra practice or 2. So we'll kind of do like a 5.1, 5.2 review on Wednesday with a quiz on Thursday. Just a heads up. Not even multiple choice, I don't think. I think it's just, let me give you a few problems like the homework from 5.1, 5.2. Won't be turning in our homework spirals just for sake of time, but hopefully your homework will be all nice and perfect and up to date. Who knows, maybe I'll have some sort of homework check on Wednesday for a bonus point or 2 on the quiz on Thursday. You guys dry your teeth? Good. Has anybody actually started on that left side?
I think I know it, but I don't know if it's the
Let me pause and tell you a quick fact, and it might change some of your directions. Using a Pythagorean is horribly illegal. Not that it's ridiculous that you thought of it. It's not. I know why you thought of it. But using a Pythagorean is horribly illegal because there are no squares.
Oh.
So it wasn't awful if you thought of it. Your brain kind of knows the formulas, you get used to them, but there's no squares. Don't think Pythagorean. Jaden got it. Reciprocal. Jaden. Reciprocal. Now, we have 2 options. Both of them are good. One of them says, secant's kind of a harder guy, so I want to change him to 1 over cosine. That's not bad. But others of you, if you thought ahead, and these, you really want to think ahead and keep considering the other side, you could have looked on the other side and said, wait, but I want him to go. So you could have also thought, let's change the cosine because he's no longer there. So we could either change the secant to 1 over cosine because our brain's like, ooh, that's going to be easier. If it gives you the self-confidence to go for it, you'll end up at the right place. Or you could think ahead and say, no, I want the secant, I'm getting rid of cosine. So I'm just going to go with whatever I hear the loudest when I say, which one should I change, secant or cosine?
Cosine.
Reciprocal property says, I did not expect it to be as overwhelming. Reciprocal property says cosine of theta equals 1. 1 over secant of theta. Oh, it's a complex fraction. This is ridiculous. We should sue. Wait. Who don't we like?
Secant.
So we're going to multiply top and bottom. My trick, at least. Multiply top and bottom, guys? Now, come on, you have to do it no matter which way you go. Put those parentheses in. Now that you have the parentheses in, you have options. I'm going to actually go on the denominator first, because that was the one that was all yucky. Secant times 1 is secant. What happens when I distribute across the minus? The secant over secant. It's 1. Now pause. Look at the top. Can you guys think ahead? Do I want to distribute that one, or do I want to leave it the way it is?
Leave it the way it is.
Because if I leave it the way it is, what can I say matches top and bottom?
It's done. Oh my
Oh.
Stop.
Okay.
Was the complex fraction scary? I would say yeah. But was it impossible?
No.
None. You could use my trick. You could have gone the other way. You would have had to put parentheses and rewritten this divided by that. You would have had to get a common denominator, then multiply by the reciprocal, and then simplify. Or you could do my trick in one step. Just saying.
Can I write Mr. Chain?
What?
Instead of a check mark, can I just write Mr. Chain?
She's thinking. Well, I like a symbol instead of like a Mr. Che.
Can I draw
It could be like a
him?
little face and then like spiky hair.
Can I draw him?
Spiky
Yeah.
hair. It's like Mr. Copper Part 2. Alright.
Just love
Oh! Don't worry, we're practicing slow and steady today. We'll practice a little more tomorrow. Now guys, listen up. Tomorrow, the second half of class, what I want to happen is I think we'll finish the examples the first half of class. I want you to have your books, so bring into class tomorrow. Because I'm going to let you work on them. If you've already worked, I'll let you ask me questions or ask your group questions. And all of that is to make Wednesday so that we don't have to go over, because the questions could take an entire class period if people get stuck on every single one, which can happen, because someone can get stuck on that one in one step, someone can get stuck on that one. It takes some math. You know, you can make mistakes on common denominators, adding, subtracting, multiplying, dividing. So my goal is for us to be working, asking questions, being able to work with others the second half of class tomorrow on the remainder of homework that you need to do. Sound good? So try tonight. Bring tomorrow your books so that there is extra time, which I'm totally planning on there being. You can work on them. How many of you guys leave your books at home because you do homework there? Okay, there should be enough for my people who leave books at home to use that. The rest of you guys, if they're in your locker, bring them tomorrow. Sound good? How are you guys on bring them home? Worst part, which side? No, we got this one.
No.
Same.
Not today.
Kiddos, there are no directions telling you exactly which way to go, but hopefully from section 5.1, you look at something like this. Pluses and two separate terms being added with denominators. And you look at something like that, somehow it gets simpler. And I'm hoping you remember from 5.1 what direction there should have been if they were trying to change or have you change that into something much simpler. What directions would have been there? Simplify the fraction could have been there, or maybe they would have been a little bit more explicit. Find the common denominator. Ready, set, go. Find the common denominator. That would have been my hint for the puzzle. Let me go check the premise out real fast. Every Monday, it's almost Wait, are you going? Go. I'm fixing the cold. You play with the problem.
Jock is too.
It was nice until it turned on.
Yes.
I have this.
38. These are properties.
Multiply the one by the other, multiply the other by the one. You might not like it.
Oh, really?
It's a little plus.
Oh,
If it was times,
yeah.
not plus. Good idea though. Good idea. Because of the addition, since the denominators do not match,
Oh.
I'm multiplied by each other.
Oh, yeah.
We're in the same group. What do you want to win?
Yes, I know. Good job, Brian.
Check this here for later.
You guys agree with my common denominator setup, right? Multiply the cosine by the other denominator top bottom, and the 1 plus sine times the other denominator top bottom. Common denominator. What he doesn't have, he needs. What he doesn't have, he needs. Wait a minute. Couldn't I FOIL these two? Did anybody FOIL it already? You'd be willing to let me know what you got? 1 plus. Good. 1 sine of theta plus 1 sine of theta will be 2 sine of theta. If you need, I'll keep that separate. That's what the left one is. What's going on over here? Good. Numerator, cosine times cosine. Denominator, we'll have those two guys again. I just heard Abby say put them together. They're the same denominator, right? Careful, I didn't kill a puppy. I foiled 1 plus sine times 1 plus sine. My outer and my inner combined. So I can go ahead and write 1 plus 2 sine. And some of you are having flashbacks a little bit to section 5.1, so we did a problem very similar in 5.1. We just couldn't see the other side when we started. They didn't give us the picture of what we were trying to say. Does anybody see a property we can use? We could distribute, but I'm not sure it's going to help. 1 plus 2 sine of theta, that's not any sort of formula I know, but wait. And sine squared, look at the Pythagoreans, go back and look at your table if you need to. Yeah. So this entire thing can become sine squared plus cosine squared, just this part can become a plus 1. Wait, I have a 1.
Adam.
So it's a 1 plus 1.
2.
Now I'm scared.
That's
-1.
remember we did in 5.1 at this point? Are there 2's in any of that table?
No.
But I can factor them out.
Yes. Gang.
There aren't 2's in any of my formulas, but I can say, well, wait, there's a 2 involved.
Gang.
Can't I factor them out? And when I divide 2 by 2, what do I get? 1. So
1.
that'll be,
Sine.
is that helpful?
No. It's not.
Is that helpful?
Okay.
You see it?
No.
Angels start singing, the lights start shining. Let's do it over cosine.
I'm scared.
Do it over cosine, reciprocal property.
I'm so scared.
Check QED on Mr. J face. All right.
Mr. J.
Kudos, we've done a lot of examples. You need to keep your notes close when you work on homework, yeah? Calc chat, is it going to show nice pretty T's? No. But if it's an odd that you did stuff on, could you go look at how they're progressing the steps they're taking? Yes, except careful. They don't show as much work as I do. You guys know that. They make these big jumps. You don't understand it. Come with other questions. We're going to have half a workday. Sound good? Okay. Your notes tomorrow, but your voice around. Get out of here. Bye, guys. See you in chapel.
You guys are crazy tonight.